Hello, in this Excel tutorial video we'll be working on the third part of Experiment 2's data workup for Chem 1B. In particular, we'll be calculating the freezing point from the two regression curves or regression lines that we generated in the second video for Experiment 2. If you recall, the last thing we did is make these two lines, and I said that the freezing point is the intersection of those two lines. To calculate the intersection of those two lines, we're going to do something called solving simultaneous equations. In other words, there's an equation for this line, y equals mx plus b, and for this line, y equals mx plus b. And both of those have to be true at that point that they intersect, and that's what we're interested in finding. So I'm going to, for convenience, start by using the x is equal to y minus b over m. This is going to be convenient because when we write the second simultaneous equation, the x is going to disappear, and when we solve for y, that's the value we're looking for. This first one is our first intercept and slope, and the second one is our second intercept and slope. It doesn't matter which one is 1 and which one is 2, but we need to keep track of which slopes and intercepts go together. To isolate y from this equation here, the first thing I'm going to do is multiply both sides by m1 and both sides by m2. And what I get here is m2 times y minus b1 is equal to m1 times y minus b2. If I expand this out, m2y minus m2b1, m1y minus m1b2. To get the y on the same side of the equation and the other stuff on the other side, I'm going to subtract m1y from both sides and add m2b1 to both sides. And what I'll end up with is m2y minus m1y. I subtracted that. I'm going to add this to both sides. So this is going to be m2b1 minus m1b2. I can pull the y out and then divide by, well, let's just pull the y out. m2 minus m1 is equal to m2b1 minus m1b2. Divide both sides by m2 minus m1, and I get my y, m2b1 minus m1b2 all over m2 minus m1. The next step is going to be to program that expression that I just derived into Excel to solve for the freezing point. And so I'll label this my freezing point is going to be equal to, and it was m2, I'll open parentheses, m2 is, I'm going to call my second slope, okay, times b1, it's my first intercept, minus m1 times b2, all divided by m2 minus m1. And that calculates my freezing point as 4.470. Without doing a full regression analysis, it's difficult to determine the number of sig figs we should have, but I would think that we wouldn't want more than 3 significant figures for certain, and probably only 2. And that's the freezing point that we would use in calculating our temperature change or our freezing point depression